Hi, everyone. Thank you for being here and thank you for having me, especially you organizers that gave me this opportunity, and also you who are participating on this amazing event that is J4K. I really enjoy to be here, all the sessions, all the time. So thank you again, you all. Let me switch to my screen. And today we are gonna talk about native images with Java, of course, and how we can make our applications up to 6 times faster just by using native images. My name is Elder Moraes. I'm a developer advocate here in Red Hat. I'm based in Brazil, São Paulo, and I'm really happy to be with you all today. Before starting talking about all those concepts about native images, let me show you how we can make one piece of code up to 6 times faster. And let's hope that the demo just works, okay? So I have here a very simple application. I'm using Quarkus, but we are not talking about Quarkus today. We really will talk about native images. But I have here just a very simple JOX-RS application here using hello and hello rest easy and so on. So no complications at all. Let me run this application just using a JVM. So I will use the Quarkus dev here, the developer mode of Quarkus, and let's see how much time it takes to bootstrap the application. Okay, my machine is a little lazy, it's a little slow because I'm running camera, sound, and so on, but that's fine. So 4 seconds, okay? If my machine was just free right now, it would take around 1.5 seconds, something like that. Okay, but 4 seconds is not that bad. So let's get this very same application, but compiled in a native image and run and see how much time it takes to bootstrap the application. If you ever tried to compile a native image, you already know that it takes some time to generate, to compile the application. So I went and generated the native image before. So because with this whole streaming and so on, it would take around 5 minutes in this machine to compile. So I let it already compiled. So if I go here to my target folder, I have here my application runner here, Quarkus, code with Quarkus runner. So it's the same application. I will just let this one down because I will have port conflict. But we have here 4.184. Let's see using native image. So target and code runner. And boom, 178. If my machine was completely free, it would run in about 17 milliseconds, 20 milliseconds at the maximum. But let's make a quick math here. Where is my calculator? Here I have 4.185. And here we have 178. So we had 23 times, okay? So we didn't reach the 60 times, but yes, it's possible even more, even faster than this. But it's already good, right? Just, I didn't need to change any code. I didn't need to create another application. I didn't need to do anything. Just by compiling the application using native image, it is running in 23 times faster, okay? So sorry, I didn't reach the 6th time, but because the streaming part. Okay, so just one alert before starting here. This is not a GraalVM talk, okay? I'm not gonna talk a lot about GraalVM here. If you would like to hear talk about GraalVM, check this one, okay? So you can scan, you can go ahead in my Twitter after this talk and check the slides that I will publish there. But this other one, it's a GraalVM talk. This talk today is not about GraalVM, okay? Another thing that I need to say is that when I was creating this talk, I asked a question in all my social media, asking people, what's your biggest challenge? What your biggest question related to native image? And I got a lot of answers, some in Portuguese, some in English. So I would like to thank you, everyone, because this talk was made to answer those questions, okay? So if you are one of those people who send me your question, thank you very much. Okay, so a little bit of context, and yes, we are not gonna talk about GraalVM, but just to give you a context, here we have a kind of schema of how the source code of GraalVM is organized. So we have today around 640,000 lines of code, and here is how it's split. So language 1,700, here the core, here the compiler. So a lot of modules, and we will not cover this today. But the native image part, it's something around here between compiler and Substrate VM. We have a guy called Native Image Builder. So the Native Image Builder, it's the main actor here today in our session, okay? All right, so let's get started. First, what is a native image? It's a technology that uses ahead of time compilation to create a standalone executable. Okay, so basically that application that I just showed you in the beginning of the session was a native image. So it's a standalone executable. What does it mean to be a standalone executable? That I can grab this executable and run in another, in my case, MacBook, without having a Java virtual machine, and it will just works. Okay, so that's what is a native image. How a native image is generated? So, of course, using the native image builder, the builder that builds native images. It performs a static analysis over all classes inside a Java project, okay, and its dependencies. And all the methods and libraries used in the runtime are mapped, and it will compile your code using ahead of time compilation to generate a native executable for a specific operating system and architecture. Okay, so if you will use, for example, a Linux, a CentOS, for example, using a AMD processor, your native image will be compatible with a CentOS and AMD processor. So this architecture and operating system is very important because it will determine the compatibility of your native image. What is embedded in a native image? Application classes, classes dependencies, classes of runtime libraries, and static code native from JDK. Why? And the next question we will answer what I was about to say. Do I need a JVM to run a native image? No. Okay, so we just don't need a JVM to run a native image. But how it works? Why I don't need a JVM? Because a native image has a runtime system called Substrate VM. It's a kind of really, really simple and small JVM. It's not a JVM, okay? So but it has some components of a JVM. So a kind of memory management, a kind of a thread scheduling, a kind of a garbage collector. So, but really, really small. It's far from being something like the JVM itself. Okay, so let's cover some limitations of native images. First, before talking about the limitations, we need to do some assumptions. The first one is all the runtime code needs to be known in the compile time. Okay, so we like to say that a native image is immutable, and it really is. It's immutable. You can't put a new code in the runtime. You can't consider new method. Nothing. Anything that is compiled, it's final. Okay, so no new code is loaded in runtime. We assume that the native image compilation is a kind of optimization, okay, because it will run your code faster, as I just showed you. But we need to assume also that not all applications are optimizable for many reasons. Okay, so when we think about limitations, we will think about compatibility, and we have 4 groups of compatibility that we will cover today. The first group is features that work but require configuration. The second one is features that might work differently. The third one is features that don't work. And the fourth is the rest, okay, things that just work. So we will cover the 1, 2, and 3 today, because what works, it works. Okay, so we'll cover details, features that require configuration, that might work differently, and things that just don't work. So first, features that work but require configuration. First, dynamic class loading. So if you use dynamic class loading, something like this, okay, for name my class, this class here needs to be in a configuration file, okay? And if the class isn't available while you are compiling the application, you will throw a class not found exception. Reflection, it's interesting because in the first versions of native image back in 2007, because 2018, reflection basically didn't work, and they improved it a lot along on the course of the years. And now we have, it works, but it requires configuration. So basically, classes, methods, and fields accessed through reflection needs to be known ahead of time. The same case of dynamic classes, dynamic proxies. The native image builder will map those elements using the calls of the reflection API. So basically it will monitor all the calls made by the reflection API. If the analysis fails, guess what? The elements needs to be informed also in a configuration file. So, and talking about the class initializers, you can just use reflection there without any restrictions, okay? Dynamic proxy, supported if the bytecode were also generated ahead of time. For example, if you have a list of interface that defines proxies, this list needs to be known in the build time. Okay, so the calls that will be mapped related to dynamic proxies are new proxy instance and get proxy class. And again, if the static analysis fail, the interface list needs to be informed using configuration file. GNI, Java native interface, another one that will require some configuration. The case is very similar to reflection, okay? It will maps all the objects, the class, methods, and fields. And for the same reasons, the items must be informed user configuration file, okay? As an alternative, you can use an API that is available on the native image package that's much easier to use than the GNI. Okay, so if you would like to check it, just go to this package down here. Okay. Serialization. So the metadata, sorry, must be informed in a configuration file as well. Simple like that. Okay, the second category here is features that might work differently. So it will work, but the behavior could change. So signal handlers, if you use signal handlers, by default, no signal handler is registered for a native image. To be registered, you must do it explicitly. So to register, just when you are compiling a native image, you can use this flag install exit handlers when building the image. Okay, so by using that's this flag, you will just have access to the same signal handlers provided by the JVM. Okay, class initializers. By default, all classes are initialized during the runtime of the image. Okay, so not in the build time. The default, it's to load the classes in the runtime, but it will it will ensure the compatibility of your application, but will limit optimization, because remember, the point of creating native image is to process as much as possible during the build time. So it will save for you that time spent on the build time, it will save on the runtime. Okay, so but for some kind of optimization and compatibility, you could change, in this case, the class initializers to the runtime. Okay, and if you but if you would like to move this default behavior from the runtime to the build time, you can do it, but it will but it will improve your startup time, and also you improve the performance peak of your application. And if you like to adjust, use the build time or use the runtime, just use these two flags here: initialize at build time or initialize at runtime. So you can do whatever you would like to do. Finalizers. So it's deprecated since Java 9, and the implementation for native image is too much complex. So they recommend this, you just don't use if you don't need it, and the behavior probably it will be different. Threads. All the methods from the Java lang thread that are deprecated for a long time, it's not implemented on native image. So for example, thread stop that is deprecated since Java 1.2 is not available on native images. Debugging monitoring. The point here is one thing that we need to think is that when we are talking about debugging monitoring, we are talking about tools that use interfaces that assume that some kind of bytecode is available during the runtime. That's how it works through debugging monitoring applications. Okay. But you don't have that bytecode available on runtime because there is no bytecode at all, because you have a native image. Okay, it's another kind of code. And that's why you have a lot of limitations when talking about debugging monitoring. So one option is using native tools as well. So for example, the GNU debugger or the vTune profiler, that are tools that work in native way, in a native approach. It will help you to have more options for debugging monitoring. And the third part here is features that just don't work. Okay, so invoke dynamic, because when you think about invoke dynamic, the method can change, and this can't happen when we are talking about native images. Security manager is not implemented in native image, so you will not work. Okay. So we now know all the limitations of a native image. So let's now check the comparatives between native image and JVM and how we can differentiate one from other. First, for native image, the startup is faster, okay, because there is no class loading. All the classes were loaded, linked, and initialized during the build time. There's no code being interpreted. Okay, there's no interpretation. There's no just-in-time compilation because there's no interpretation. And even part of the heap were generated during the compilation. So you have a lot of the process that is usually done in the runtime in a JVM, in the native image is already done. The footprint is smaller. Okay, so because there is no metadata for loaded classes, there is no profiling data for JIT optimizations because there's no JIT. There's no sorry, there's no cache for interpreted code, and there's no JIT structures because guess what? There's no JIT. Okay, so why not using native image for just everything? Because it's just incredible. It's faster. There's the footprint is smaller, and the startup is great because there's no silver bullets, right? So let's check why we are not using native image for everything. First, because there's no support for JVMTI, Java Virtual Machine 2 interface. If you use it, there's no support. There's no support for Java agents, and there's no support for JMX, Java Management Extension. So if you need to use those tools, it will not work with a native image. It is good, but just for small heaps. Why? Because there is a very small garbage collector in the substrate VM. It's called serial GC. It's very limited because if your heap is too big, it will just freeze your application just to perform the garbage collection. So it's not worth it to use it if you have a very big heap. Okay, so it just works well for small heaps. There is no runtime optimization. Okay, it's not good or bad, it's just a fact because all the optimizations are final. There is no just-in-time compilation, and now the optimizations, it's done once the application is compiled. So the performance of that application will be always the same, all right? There's no support for head dump and thread dump, or there is, but only for enterprise edition of GraalVM. We are not talking about GraalVM, but there is two versions, community edition, enterprise edition, and you have head dump and thread dump in enterprise edition, okay? But we are covering here just community edition. Okay, so I have the comparatives, I have the limitations. When should I use native image? I know that it will not work for everything, but it will work for what? So let's check here. When your application is small, it's a small application, can be invoked multiple times in a short period of time, and it has a short life cycle. So for example, CLI apps and serverless functions. So imagine that you have an application that will be called and will perform some task in 17 milliseconds, 20 milliseconds. And once it is done, you can just let it go. So that's a really good case for a native image. But if your application is big, have a big life cycle, it will make no difference if the startup will take like 10 seconds or 1 minute. It will stay just running all the day. So it's better to have a JVM because you have some optimizations in runtime. Okay, so that's where to use, where not to use native image. Yes, we are not talking about Quarkus today, but I need to make just some clarification here related to native image and Quarkus, because all the optimizations made on Quarkus are independent of using native images or not, because I heard a lot of times people say, well, Quarkus is fast because of native image, Quarkus is fast because of GraalVM, and that's not the case. You can use Quarkus with whatever JVM that you would like to, but if you would like to generate a native image using Quarkus, yes, then you're gonna use GraalVM, but that's the only case, okay? But if you would like to use Quarkus to build a native image, all the extensions available on Quarkus are 100% compatible, okay? You only need the native image builder through GraalVM or through Mandrill. And what is Mandrill? Okay, Mandrill is a fork made from the GraalVM Community Edition. And in general, it's just an OpenJDK in the native image builder. So if you recall that image when I showed you all the modules of the GraalVM, all those modules is not considered here on the Mandrill. We have just the OpenJDK in the native image builder. Why we did that? Because we would like to make better the support of native image generation for Quarkus, and also to bring a better support for Red Hat customers, and in the end of the day, to improve the contribution, because all the codes that we made for Mandrill, all the issues that we solve, all the new features, whatever that we contribute to Mandrill is contributed back to the GraalVM Community Editions project. So we are here both improving our support for our customers, we improve the support for Quarkus generating native image, and we are improving the GraalVM Community Edition project itself. All right. So, my friends, I would like to just finish here to talking about the Red Hat developers. It's a program here at Red Hat where we create content for developers about Quarkus, about Java, containers, microservice, GraalVM, Mandrill, native image, Kubernetes, and so on, cloud native. So content made for developers. In fact, so if you like to check it, just go to this URL or scan this QR code here. All right, so thank you very much. I don't know if you have questions. Yes, I have some here. Is native image operating system independent? No, it's not independent. If you generate a native image using Linux, it will just run on Linux. If you have on macOS, just macOS and so on. But it will not, it's not bad for backward for compatibility in Java, write once and run anywhere. Well, not if you are using containers, for example. So if you will run your application inside a container, the operating system is always the same. So there is no problem. Does native image plays well with containers, Docker? Yes, it's perfect. As I just said here, the last question. I don't know if you have more questions. If you're not, guys, you are always free to reach me on my Twitter. The either is here, YouTube, Instagram, whatever social media you like. Always available. Just ping me a message and I'll be happy to talk to you. See you next time. Bye-bye. Have a great day.